Okay, first, Marco, you're amazing. You're the most generous person on earth, and you've just been amazing. Thank you. The university, thank you, and the Department of Psychology and the Neuroscience Institute, thank you for the honorary memberships. I really appreciate that. Marco's lab, it's been fun hanging out with all of you. Ariana, I have to give you a special thanks because of all you've done, and Matteo for the great sound work last night, and also Raffaella for technical help with all of the procedures and making my visit here possible. And of course, all the speakers, thank you so much for coming and presenting. It was wonderful hearing all of you. And finally, the audience, of course. So thank you all. So, this has all been about me, obviously. And when you have something like that, it makes you kind of like wonder, think, ruminate over what are all those things that happen that somehow I ended up here in Turin today for all this to happen. I mean, we've heard some of the research, but I just want to kind of reminisce a little bit here by saying that it's not a straight line, obviously. It's more like this. And along the way, there are... Is there some way to do this without having to click this wheel? How do you...
You have to use this one.
Which one? This?
Okay.
Right. Okay. So lots of students, postdocs, technicians, volunteers, colleagues, visitors, random encounters, and also musicians, of course, Daniela and Colin, and many others. And also mentors, and I have my mentor here today, Mike Zaniga. So there was a time back in the 1970s when I walked into Mike's lab and he said, why not, in terms of joining him. And this was Mike a few years earlier when, I guess, were you a graduate student at this point or a young professor? Mike wasn't that much older than me. He's 10 years older than me, so we were not that far apart. And he was an incredibly great mentor, and everything I've done, Mike, thank you. And so I want to thank you by giving you a dedication. And it's not for this, I'm not dedicating my talk to you today, but my new book. So thank you, Mike. The book is called The Deep History of Ourselves, the 4 billion year story of how we got conscious brains. And it's my 40-year story, I guess, of how I got hooked on consciousness is through Mike. And it all happened one afternoon in Vermont when we did this experiment. As Mike said earlier today when we were talking, that chicken is paid for a lot of stuff. Probably at least 6 educations. So many of you have probably seen this. We presented a snow scene to one side, one visual field, and the chicken claw to the other side, and the left hand goes to the chicken claw, sorry, the right hand goes to the chicken claw, left hand to the snow shovel, and you ask the guy why he's doing, excuse me, why he did that, and you're talking to his left hemisphere now, and the left hemisphere says, well, saw a chicken claw, so I picked the chicken, and you need a shovel to clean out the chicken shit. Is it shit or shit? I remember it as shit, but I know you usually say shit, but we'll go with the dirty version today since we're having a good time. So, and what we ended up concluding was that, he generated these narratives, and we saw this often in these split brain patients. And this idea that narratives make consciousness has been something that I've carried through all these years. It's always been at the end of my books and so forth. And now I've written a book about it. And I'll tell you a little bit about that. But first, that's how I got from doing the stuff to doing this theory of consciousness, is starting with that. But the book is this. So this is the history of life here. And the question is, why do we have to know something about all this stuff 4 billion years ago to understand this and even this. And I think Emerson has a good quote here, which is, as soon as there's life, there's danger. And there are two meanings to that. One is that all organisms face danger at all points in their lives. So you've got to, when you're from the zygote to the embryo to the fetus, baby, child, adolescent, adult, there's danger throughout life. And I think that's probably what Emerson meant, but there's another meaning as well. Until there was life, there was nothing to be harmed, so there was no danger. And that's why we have to understand this in the big picture. So the first cells that lived billions of years ago had to survive danger in order for their life to be continued so that they could reproduce and perpetuate the rest of the history of life. So how do I get from 4 billion years ago to Pavlovian conditioning and then to consciousness? So let me just talk. I'm not going to go on too long, so let me just bear with me a little bit. So over the 35 years that I've studied this stuff, we've learned a lot, and we've heard a bit about that today, the behavior, the systems and cells and circuits, but also the molecules. And what's interesting, if you look at the molecules in the lateral amygdala that are involved in Pavlovian fear, threat, conditioning, I'll call it threat since that's what I prefer, are very similar across many diverse levels of evolution. Many of these were first discovered through Eric Kandel's work in the aplysia. Here we see an aplysia. And so if we take this as evidence of some kind of common ancestry of all this, where does that take us? Well, that takes us about 580 million years back, which is where the ancestor of things like snails and the ancestor of things like humans and rats was. So we have to go back at least 580 million years ago to understand the molecules that are underlying conditioning. But Seth Grant, who was a postdoc at Eric Kandel, did some studies to look at what he was interested in was the evolution of Nmda receptors. And if you see it, of course, you see Nmda receptor components in, where's my cursor? In rodents and flies and other invertebrates, but also you see them in radial animals like jellyfish and hydra, but in sponges, but also in protozoa. So protozoa, of course, are single-cell organisms. So protozoa are single-cell organisms, and they don't have a nervous system, but they behave. They even learn. There were early studies by Herbert Spencer Jennings in the late 19th century showing conditioning in protozoa. But also bacteria learn and behave. So here's bacteria. They basically have two behaviors. They run and tumble. Mostly they're just moving. And then if they encounter something useful, they keep moving towards it so that the gradient of the chemicals gets higher and they absorb what they need. But if it's toxic, they tumble away. So they can approach and avoid just like we can. So we have to go back to the beginning of the Earth to begin to think about all this, and the prebiotic chemistry that existed before there was any kind of biochemistry. Mike talked a bit about this in his talk. But then you have precellular biochemistry where you have RNA and DNA are being made and chemicals are being replicated. But at some point you get protocells in which the RNA and DNA are sequestered inside a bubble and ultimately inside a membrane. And from there you get the first organisms. And it looks like that these hydrothermal vents were important in forming these protocells that then escaped with a membrane out into the water. So that's why I think it's important that we talk about this long history, because if we look at the things that are required for a cell to get through the day, it's got to make energy, balance fluids and ions, thermoregulate, withdraw from harmful agents, and then reproduce for its kind to survive. And those are the same things that we have to do: make energy through eating, balance fluids and ions, withdrawing from harmful agents, and reproducing. So And behavior plays a key role in many of these things. So energy needs we solve by eating, fluid and balance ion control we drink, defense we freeze or flee, reproduction we copulate. So when we do these things, we put these subjective state terms on hunger, thirst, fear, and pleasure, and we apply those back to other organisms. So, the one thing that's important, though, is when we think about all this, that the way an animal does this is not generic. All animals have to do these things, but the way they do them depends on the kind of body they have. So some animals will run away, others will fly away, others will swim away, others will slither away from harm. So it's not what's evolved is not the behavior, but this kind of strategy that is necessary to keep the organism alive. So organisms have two behavioral options for accomplishing these things: approach and avoidance. These are not fundamentally psychological. They reflect the fact that we live in an environment that is geometric, Euclidean space. So if there are two objects, they can only be closer or further away. So there's no psychology that's necessary to be closer or further away. Psychology comes much later. So if we look at the natural history of learning, we can see that, as far back as bacteria, there's evidence for simple mere associative learning through Pavlovian conditioning. The next thing that happens is in invertebrates, you can also get non-cognitive learning or stimulus response learning, the formation of habits. To get to the next big level, which is goal-directed instrumental conditioning, you got to get to mammals and birds. And conscious deliberation, I think maybe that's a kind of human thing. Oops, I'm going the wrong way. So here's two wild ideas that I float in this book. One is let's start with the usual story. Mammalian brains evolved emotion circuits, namely the limbic system. Emotions then paved the way for higher cognition in the neocortex in primates and language-based cognition in humans. So that's the kind of usual thing that would mean the amygdala fear in the amygdala helped get all these fancy cognition things because it was based on that in some sense. But suppose emotions are not hardwired states encoded in subcortical areas, but instead are cognitive events assembled in neocortical circuits. That might mean that the evolution of cognition and cognitive deliberation in animals is what made emotion possible rather than the opposite. So I think this will probably not be liked by a lot of my colleagues, but I think it's worth considering, because it leads to the second wild idea, which is emotions didn't arise via natural selection, but instead as a series of acceptations that were later selected for. So the first acceptation was language. I recently came across this paper by Kolodny and Edelman. It said language emerged through the coupling of primate skills, including communication, hierarchical deliberation, and tool use, and made culture possible. That was their proposal. But I want to take that further. That language also gave us personal pronouns, I, me, mine. And many developmental psychologists, Michael Lewis, for example, emphasize the importance of personal pronouns in the ability to have an awareness of self as a subject, as opposed to what we might think of as awareness of self as an object. So body sensations and all of those things allow us to be, to have an awareness of ourself as an object, and maybe many animals have that kind of awareness. But perhaps awareness of self as subject requires these personal pronouns. And this allows us to make a distinction that Tulving proposed for memory between autonoetic and noetic consciousness. Autonoetic consciousness requires the self in time. So you have to be able to mentally time travel to your personal past and your personal possible future. Now, perhaps that's a specific human characteristic, as Tulving proposed. But other animals might have more kind of noetic states of consciousness, where they're aware of objects or even of some crude body state, but not necessarily aware of themselves as the subject of that. So that leads to acceptation 3, which is emotions are a special class of autonoetic experiences that occur in biologically or psychologically significant situations in life. The biologically significant ones would be the ones that are usually talked about in terms of basic emotions, and the psychologically ones more in terms of social and acquired emotions. So, let's go back now to, once I left Mike's lab, I had to find something to do, and I decided that we were sitting in a bar in Vermont after testing a split-brain patient, and having our favorite drink at that time, which was Jack Daniels, and after the second or third one, Mike said, "You know, there's not much work on emotion in neuroscience." I said, "Okay, I think I'll do that." And so after I left Mike's lab, I decided I was going to study emotion, but there wasn't any good way to do that in humans at the time. So I turned to rats, and Mike knew about my interest in this. So in the early 1980s, he invited me to write a chapter for the Handbook of Cognitive Neuroscience. That's not the big book that everybody is so familiar with, the cognitive neurosciences. It was a smaller book, but it was, I think, the first kind of statement of cognitive neuroscience. And I wrote this chapter on emotion. And this is before I did any work on the amygdala or anything. But I proposed that an emotional stimulus, this is all based on the split brain idea, the stuff we were doing back then. An emotional stimulus goes through a sensory system, goes to a subcortical circuit to elicit emotional responses, but goes to a cortical circuit to elicit emotional feelings, which are narrations of your activities of your brain and body. So after working on the amygdala for a long time, I still had, to this day, have the same basic idea. Danger goes to the sensory system, it goes to the amygdala to produce the responses, but goes to cortical circuits, and now we call those working memory, to generate feelings. But more specifically, this requires cognitive, but this only requires a behavioral account. So in terms of Haquan's statement about B.F. Skinner, I think he's right that we don't need consciousness to explain behavior, or most of the behaviors we study in animals. But I think we do need it to explain some aspects of human behavior, such as those that are driven by our actual fearful experiences. So, from 2012 onwards, I've been on this kind of tear, trying to rethink the way we talk about fear and so forth. And this is the model, which is basically the same thing. But it's, I'm sometimes accused of viewing these as two separate systems, but they're not separate. They run in parallel, but they interact. So that your cognitive awareness of being in danger includes information about the fact that your body is responding in a certain way. Also, amygdala connections to the cortex. Amygdala activates arousal circuits in the brain, and those influence all the cortical processes as well. So it's not like they're completely independent, but I think the difference is that what the emotion is determined by your cognitive understanding of the situation you're in. And what the bottom-up stuff is doing is kind of modulating the intensity. So it's like you go to a restaurant in New York and the music is really loud, and some old person asks the waiter to turn it down, and they turn the music down. And the song is the same, but it's just not as loud. And I think that's what happens with amygdala damage. The intensity of the experience is no longer there, but as the woman Liz showed, she said, "Yeah, I'm afraid. It's just, I don't sweat." So she doesn't have all the arousal, but she's got what we call fear. Because why? Because she understands what fear is from her perspective. And I think that's a really important idea. That I'm going to put this now into the way I think about all this, and this is related to what Haquan and Richard Brown and I are now working on in terms of this higher-order theory of emotion and various other things that relate to that. But the basic idea is that you've got all these kinds of things in the brain. None of them are emotion things, per se. Sensory processing, semantic memory, episodic memory, self-schema, all those can be monitored, appraised, attended to by working memory, and we can then have metacognitions, introspections, and give verbal reports. But none of the, so this could be, your awareness of an apple. If you include a self schema as part of the awareness of an apple, then it becomes, a kind of personal relationship to the apple, which is, related to episodic memory as well. But it's not an emotion until we add some of these other ingredients on the other side. In terms of higher order theory, these are all lower order or non-conscious ingredients or factors. So let's talk about the old survival circuit here. So that would be the amygdala that we know and love. And I recently was asked something about that and responded, the poor amygdala, we ask so much of it. Because there's so many things that are attributed to it. And one of them is, of course, fear. So fear or survival circuit activity is important because it activates brain arousal, it activates all the body responses that then feed back, and then all of those things can be monitored as well. But you can be afraid in lots of different ways. You don't need this amygdala predatory defense thing to be afraid. You're stuck on a mountaintop and your hypothalamus is telling you that your energy supplies are low or that you're in risk of hypothermia or dehydration. Then you're going to be afraid of that. So fear has nothing to do necessarily with the predatory defense system. It's just your cognitive awareness that you're in harm's way. And the only way to explain that is by thinking of it in terms of cognitive terms. And the way we generate these, I think, cognitive emotions like this is through emotion schema. We build these up from the earliest days of life and begin to have experiences with danger, and we begin to know what they are. But everything that I know about danger that I've acquired throughout my life is different from what you know about danger. So we each have our own personal fear schema. And the reason we have a fear schema is because we have a culture, as Stefan was saying, that gives us a word for that. And some cultures have words that mean different things or that don't exist in other cultures. So our self-schema is personal to our individual self. What I think of as fear, what puts together my fear is different from what puts together your fear. And what puts together fear in the United States, where we use the word fear, is different from what puts together fear in Germany or any other country or Japan. So these are very flexible things, but we have words that we hang them on. You don't need the words to have the experience, but you need the words to categorize it. In English, we have 37 words for variations and different variants of fear and anxiety. And without those words, we can't have those conceptual partitions to know the difference between just kind of a low-level concern versus what we might just generally call fear versus panic or horror or terror or all these other variations that we have. So our fear schema is personal, and in order for that to happen, you have to have this subjective self, this kind of self as subject as opposed to self as object. So that's my big picture of how this works. And here's the idea of the fear schema. You have a bunch of things that are stored, that you've built up over your life that constitute the schema. But all you need is probably the presence of a threat to pattern complete that schema into the experience of fear. If your heart is beating faster and escape is not possible, then it's a fait accompli. But the fact that a threat is present is all you need. So the woman with amygdala damage that said, yes, I feel fear, all she needs is the presence of that threat to subjectively now activate what she calls fear. She's lived without this amygdala for a while, so she doesn't need all the body stuff and the brain stuff that goes with that, because her fear is her fear. And Antonio Damasio once introduced the idea of as-if loops to account for how, his theory is that body feedback is defining what the emotion is. But he said, but sometimes the body feedback isn't there, and we simulate it with an as-if loop. For me, all of emotion is an as-if loop, because it's all a simulation that we cognitively do on the basis of our fear schema. And thank you very much.